Guys, in this part of the session, I'm going to walk you through one of the essential steps when working with TS Master, uploading a CAN database and tracking communication on the bus. TS Master allows us to work with DBC file which contain of the structure of the CAN messages, signals, and the nodes that communicates over the network. Uh, First, we should open the TS Master application. And after we see a second, we click OK here, and you can click here, create new project, empty project. After we wait, double click to maximize it in full simulation mode, where in order to update your DBC file, in order to see the signals, the messages that uh, send that through them, you click here, database in data analysis section, and click on show CAN database. After clicking on it, you here can import your DBC file. Here I have a DBC file that, for example, that I can import it. Click open. It takes a few seconds to be uploaded. Once the DBC file uploaded successfully, you can here see signals, messages, and nodes or ECUs. So as you can see, I can see the signals of the DBC file, messages that contain those signals, and the nodes that send and that are responsible for sending and receiving signals. In the previous video, we explored how to upload a DBC file into TS Master and how it allows us to view the signal. In this video, we will take a step further and discuss two important components, the DBC file and the BLF file. With a BLF file, which is stand for the binary log file, uh, is the recorded data by Tucson hardware, which is connected directly to the vehicle's OBD port, and we can capture raw CAN data from that and use TS Master to convert the binary log file data to a physical and graphical illustration. Let's see some of the features of DBC file, and after that we will upload BLF file and try to see the graphical and physical illustration of each signals. As we explained in the previous video, when you upload the DBC file here, you can see the signal message and note here. When you click on any random signal here, you can see the property and the feature of that signal based on the CAN database. For example, let me search it here, yaw, to see the yaw rate signal here. I click on it and we can see the definition and database field. For example, we can see the minimum, the maximum, value type, unit, factor, offset, and initial value, and any feature that is considered by the CAN network engineer in the DBC file. And we can check it too, and that we will discuss about it a little second later. For the sake of uploading the BLF file, we simply drag the BLF file and drop it here. As you can see, the BLF file is uploaded. You can see the acc.blf file here. After uploading it, for the sake of seeing the physical and graphical illustration, you come to the data analysis section, click on graphics, click on add graphics. You can see the empty space here. When you here click on add CAN signal, you can see all of the signals that you previously added through the DBC file. For example, let me search again Yaret here. When I click on Yaret, I again can see the feature of that specific signal. When I click I apply, after OK, you can see that the signal is added here. When we run the BLF file, let us run it. You can see the status of the signal from n.a change to a random value, the specific value to the signal. You can see the signal here. The horizontal axis is time, the vertical axis is the value based on the unit of that signal that can be seen in the properties of the signal here. For example, the unit here is radian per second. Some of the features that is very important to notice here is that when you click on this car, for example, when you want to a very important signal or a specific point that is very important to you at that moment, you can click it here and change the color to be more highlight for you. When you click it, the color of that signal change. There is a lot of features here. For example, if you click on adjust horizontal and adjust horizontal and adjust vertical fit here, you can see the signal properly and more convenient to track. When you click on these two options here, you can see easily the value of the signal in that specific time. For example, in the 5 second, you can see the value of the signal here. Yeah. Yeah, that's the way you can see the physical interpretation of the recorded data. When we click on add and again we click on add can signal, we can choose multiple signal at once time. For example, let me randomly choose signals here. Yeah, I just randomly choose them. Applied, you can add it. We can see all of these signals that I randomly choose added here. When I again click on start playback, the BLF when I run the BLF file, let us run it. You can see that another signal just added. Some of them are constant, so it seems to you just like a horizontal line here. You can see that some of these signals, the status of this signal is n.a. So it means that they are not defined or something wrong with them, and the TS master doesn't interpret BLF file properly based on CAN database here. There is one thing that I really want to talk about is gauge. When you click on gauge and add meter, you can see empty space here. When you click on can, you can see all the signal in DBC file here. Let again search. So sorry, yeah, right here and apply and add it. You can see the yard rate. And when we again run, you can easily see the changes over time of ER rate in VLF file, the recorded data. You can also check the minimum and maximum value in the property of the DBC file with here engage. That is, as you can see, is correct. Thank you so much, and I hope you learned about TS Master here a lot.